So 3.5 is all about derivatives of trig functions. We're just going to have so much trig, you guys are going to be great at it by the time we're all done. So let's first consider what the original functions look like. So if this is my f of x, what do we do to find f prime of x? We look at the slope of f of x. So the first thing you always want to do in graphing derivative graphs, look for zero slopes first. So here we have a zero slope here, here, and here. So that corresponds to a zero y value. Because remember, in the derivative, the x value is the same, and the y value is the slope of the tangent line, the derivative. So see how this is a negative slope of the tangent? That means this would be below the x-axis. Then we've got positive slope from this zero slope to this one. So that means this is above. So if you notice, we know sine goes up and then down. This is going down and up. The derivative of cosine is just negative sine. So let's do the same thing with sine. Look for all the zero slopes. So this will be a zero, this will be a zero, this will be a zero. Then we look for positive and negative slopes. So here we have a positive slope. That means it's above the x-axis. Then we have a negative slope. That means that's below the x-axis. That graph looks pretty much like cosine. So the derivative of sine is just cosine. So you pretty much have to just memorize all 6 trig derivatives, and you'll get better at that, I promise. So go ahead and copy all of these down. We'll actually talk quite a few strategies. Maybe pause the video, write them all down. One of the big things that people always notice, all the cos are negative. So a lot of times what I do, I write the 6 down vertically, sine, cosine, tangent, cosecant, secant, cotangent. And then I just start filling stuff in. First of all the cos are negative. All the other ones are positive. Sine is cosine, cosine negative sine. Those are the easiest 2. Now, tangent is secant squared, cotangent is cosecant squared. The last 2 start with themselves. Some class used to say cosecant is cosecant, cotangent, and secant, tangent. So this is just about doing a lot of stuff with practicing your trig derivatives. Okay, so for example, if y equals x squared sine of x, here's where the product rule becomes very, very important. Okay, we're taking x squared times sine of x. There's nothing I can simplify with that. I have to use the product rule. So y prime, so the product rule, I take the first function times the derivative of the second function plus the second function times the derivative of the first function. And it's really that simple. That's all that you're going to do. All right, letter B tends to be a little bit more. First of all, it's a quotient. All right. With this being u, I'm actually going to write this du dx. You can write u prime if you want. It's just a good habit to practice all the different types of ways you can write derivatives so that you're not uncomfortable when we have to use this method. Okay, so with the quotient rule, the very first thing we do is start with the bottom. And if it's a quantity, put it in parentheses because you need to square the bottom. Whatever you write on the bottom, write on the top. Oops, helps to do the rest of it. So we do the bottom times the derivative of the top minus the top times the derivative of the bottom. Now be careful. So the derivative of a constant is 0. Then the derivative of negative sign is negative cosine. So the sign derivative will always have the same sign. Okay? Because I know the derivative of positive sign is positive cosine, so the derivative of negative sign is negative cosine. Okay, so here's where the quotient rule is kind of a pain. We need to simplify this. So I'm going to distribute my negative sign back. And then when I take this negative cosine times this negative cosine, I get positive cosine squared. This is going to be really important. Anytime you have sine squared plus cosine squared, ding, 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 this is a Pythagorean identity. Sine squared plus cosine squared equals 1. One of the most important identities. You're going to use this all year long. So I can replace this whole thing with a positive 1. Okay, now if you notice, look at the numerator. Negative sine x plus 1 is the same as 1 minus sine x. So I can cancel one common factor of 1 minus sine x. I'm left with 1 on top and 1 minus sine x on the bottom. So I would say on the free response, you could maybe get away with this part here. But there's quite a few multiple choice questions. You'd have to be able to simplify it all the way down to find the correct answer. Simple harmonic motion, just think about like if you've got a weight on the end of a spring bobbing up and down. And so if you look at the example on the next page, we're looking at the S function. They want to know velocity and the acceleration. That's just SVA. So if S is 5 cosine t, the derivative of S is velocity. The derivative, now keep in mind, I don't have to use product rule because 5 is just a coefficient. It's not like a function. It's just a coefficient of cosine. The derivative of cosine is negative sine. So the actual full derivative is negative 5 sine. The derivative of velocity is acceleration. The derivative of sine is positive cosine, so it stays negative 5 cosine t. Okay, this one's always kind of a funny thing. I don't think I've ever seen a single AP question that deals with jerk. Jerk is just the third derivative. Kids have kind of, I think somebody actually made a t-shirt one year and it said, don't be a third derivative. And it was kind of a joke just because no one in the entire school knew what it meant except for the kids in calculus. So think of the jerk is the derivative of acceleration. It's the third derivative of position. We could even say it's the second derivative of velocity. So if we have SVA, first derivative, second derivative, jerk is the third derivative. So the jerk is caused by constant acceleration. So think of like if you're in a car and you slam on the brakes, that's like a jerk. So think of jerk that way. So the jerk of gravity, because gravity is negative 32 feet per second, jerk is 0. This explains why we don't experience motion sickness when we're just sitting around. Okay, finding the tangent and normal lines. So think about whenever you find an equation, your brain should think point, slope. So go ahead and get your calculator and plug this function into your y1, and then go back to your home screen, and let's find, because we're looking for it at x equals 2. Let's actually find what this is when x is 2. No, I didn't want that there. y1 of 2. There we go. If you don't remember how to find the y variables, once you get your equation plugged in, go to your home screen and you go alpha, the green. Hang on a minute. If you go to alpha trace, the green trace, you have all of your different y functions you can use. So click on y1, hit enter, and then do a parenthesis, then 2, and then you're going to get negative 1.093. So the point we're going to use is 2, negative 1.093. All right, tangent and normal. The slope of the tangent is the derivative. So the next thing we need to do is take the derivative. Oh, and make sure that your mode is always in radians. If you did not get that same answer, you might need to make sure you changed your mode. Okay, so this is a quotient rule. So we square the bottom. Always square the bottom first, because whatever you have on bottom is what you start with on the top. The derivative of tangent is secant squared minus the top times the derivative of the bottom. Okay. All right. If we plug in 2, this is a hot mess. We're going to actually go back to our math 8. So turn your calculators back on. Get on your home screen. Math 8. You always put x in the bottom next to d. In the middle, what it's going to look like is this. X here. This you want to use your y1, but that's only if you enter this into y1. So make sure you've done that. At x equals 2, this will calculate our numerical value for us, and we get 3.433. This is our tangent. Remember, what's our normal? Opposite reciprocal. So then go to the calculator. You're going to push x to the negative 1 right below the math button. And we need to make it negative because our tangent is positive. And when you hit that x to the negative 1, it finds the reciprocal. So then we've got our point, both our slopes. Now we just write our equations. Y minus our y equals, let's do tangent first, the slope times x minus our x. Now remember, this is from the book. I bet I didn't use my calculator in my notes. So we typically want 4 decimals. Then our normal. And that's this one. So this one was all calculator. Although I just wanted you to have practice on finding the derivative by hand. And this is really helpful. On tests and quizzes, you're going to have to find this by hand, even if you use the calculator to find the final answer. And last but not least, notice this is the second derivative. So the first thing we're going to do is find the first derivative. The first derivative of secant, if you use your notes, is secant tangent, which means the secant and the tangent are being multiplied. So then our second derivative is a product rule, u, v. So we do the first times the derivative of the second plus the second times the derivative of the first. And we can clean this up just a little bit because this is multiplying 3 secants, so that's secant to the third. Always make sure, this is really important, whatever variable is here has to be through after every single trig function. Plus here we have 2 tangents, so that's tan squared x secant x. And that's it.